Hello viewers, in today's session we are going to discuss an important and conceptual problem from Dirac delta function, and here we have to find out the Laplace transform of delta t minus 2 over t, where delta is the Dirac delta function, right? So here we are going to use an important property of Laplace transform, and the property says that the Laplace transform of the function say f of t divided by t is given by the integral that is s to infinity, and here we have f of x dx, right? So this is an important property of Laplace transform, where we have the Laplace transform of a function f of t divided by t, right? So that's why this is called division by t. So this function f of t is divided by t, and the Laplace transform of f of t over t is equal to the integral that is from x is equal to s to infinity, right? And where the Laplace transform of this function, that is f of t, is denoted by f of s. So here we have the capital F, and here we have the capital that is the small f. So now let us compare this expression with this one, that is the Laplace transform of f of t over t. So if we compare these two functions, then here we have in the denominator t, here also we have t in the denominator. So we can take the function f of t, that is capital F of t, as the delta function, that is a delta of t minus 2, right? So now due to this property, we can now write the Laplace transform of delta of t minus 2 over t is equal to the integral, that is x is equal to s to infinity, and here we have a small f, that is f of x dx, right? So once we know f of s, then we can easily find out f of x, right? So in order to find out f of s, let us write the Laplace transform of this function, that is the delta function, right? So f of s is the Laplace transform of f of t, that is we have delta of t minus 2, and by definition of Laplace transform we can write here 0 to infinity e raised to minus s times t, and here we have the function that is f of t, right? And for f of t we have a delta of t minus 2, and here we have dt. So here we have used the definition of Laplace transform of f of t as 0 to infinity e raised to minus s times t, and here we have f of t dt, right? So now we can easily find out the value of this integral by using the definition of Dirac delta function. So we know that if we have this integral minus infinity to infinity, and here we have say a function g of x, and here we have delta x minus a dx, then the value of this integral is simply equal to the value of this function g of x at this point, that is x is equal to a, right? Because we know that the delta function it exists only at this point, x is equal to a. So here we have g of a. So now if we compare this integral with this one, then here the limits are from minus infinity to infinity, but here we have 0 to infinity, and the important thing is that this point, that is t is equal to 2, this point must belong to this interval, that is 0 to infinity, and it is quite clear that t is equal to 2. It belongs to the interval 0 to infinity, and here we have e raised to minus st for this function g of x. So here we are taking the variable x, and here we have the variable t, right? So we have g of t as e raised to minus s times t, and the value of a is 2, right? So a is 2, so the value of this integral due to this definition is given by g of 2, and g of 2 can be obtained by replacing this t by 2. So we have e raised to minus s times 2, that is e raised to minus 2s, right? So the Laplace transform of delta of t minus 2 is given by e raised to minus 2s. So f of s is now equal to e raised to minus 2s, and here we need f of x. So f of x can be obtained by simply replacing this s by x. So we have e raised to minus 2x. So now the Laplace transform of delta of t minus 2 over t is given by this integral, and here we have now s to infinity, and here we have f of x dx, and f of x is e raised to minus 2x and dx, right? So now the Laplace transform of delta of t minus 2 over t is it can be easily calculated by evaluating this integral. So now the integral e raised to minus 2x is given by e raised to minus 2x over minus 2, right? So we have e raised to minus 2x over minus 2, and the limits are from s to infinity. Now let us take minus half outside, and here we have e raised to minus 2x, and limits are from s to infinity, right? So now we can substitute the limits, and we'll take the difference. So we have when x tends to infinity, then here we have e raised to minus infinity, right? Because when x tends to infinity, then e raised to minus 2x tends to e raised to minus infinity, and e raised to minus infinity tends to 0, right? Because e raised to minus infinity can be written as e raised to 1 over e raised to infinity, and e raised to infinity tends to infinity. So 1 over e raised to infinity tends to 1 over infinity, that is tending to 0, right? And then we take x is equal to s. So we have e raised to minus 2s. So now we have minus half, and e raised to minus infinity tends to 0. So here we have 0, and then we have e raised to minus 2s. So multiplying negative and negative, we get positive, and we have half e raised to minus 2s, right? So the Laplace transform of delta of t minus 2 over t is given by 1 over 2 e raised to minus 2s, or 1 over 2 times positive 2s, right?